All right, this is lesson 3.5, linear equations and problem solving. We're drawing diagrams to help understand real life problems. We're using tables and graphs to check our answers. So we're using diagrams, tables, and graphs today, beginning on page 160. Example number one is visualizing a problem. A dog pen says you have 112 feet of fencing to enclose a rectangular pen for your dog. To provide sufficient running space for the dog to exercise, the pen is to be 3 times as long as it is wide. Find the dimensions of the pen. So the first thing you want to do based on this description is draw yourself a diagram. Now it's already done for you, but this is to show you an example of how to do it. So you don't have to be an artist to draw a diagram. Just draw something that you can visualize. Okay. It says it has to be 3 times as long. Well, you don't know how long either one of them is. So if the width is going to be x, the length has to be 3 times whatever that is. So the length has to be 3x. And that's why we have the picture that says 3x on the bottom and x on the side. So the verbal model is the perimeter is equal to 2 times the length, because we know if we have an x here, this one's going to be x as well. That's why it says 2 times that, plus 2 times the length. We already have 3x. We know there's going to be another 3x, 2 times that. So your perimeter, when you label everything, just using a problem-solving model, your perimeter is 112. That's how much fence you had. Your width is x, and your length is 3x. So those are all your labels. Okay. Then just plug it into the verbal model. The perimeter is that 112 number. That's why that comes first. Equals 2 times your width. Our width, again, is unknown. It's x. Plus 2 times your length. Again, our length is unknown, but it's 3 times whatever the width was, and that's why it says 3x. So now we have an equation that says 112 is equal to 2 times x plus 2 times 3x. So now just simplify the right-hand side. 2 times x is 2x. 2 times 3x is going to be plus 6x. So 112 equals 2x plus 6x. Then combine your like terms, 2x and 6x, and you get 8x. So now 112 equals 8x. And in order to get x by itself, divide by 8, and you get x equals 14. Therefore, the width of the pen is 14 feet. The length of the pen is 3 times that value of x, or 3 times 14, which is 42 feet. Okay, this is a real life problem that you may use one day. You might not ever fence in a dog because you might hate dogs, but there may be something that you need to go around something and you got just enough to cover it. You want to see how wide and how long it can be. This is the exact same problem you'll use. Okay, don't copy this problem down. It's not on your sheet, but copy down the pertinent information and take a shot at doing this one. Take about 2 minutes to do this one. See if you can figure it out, and we'll work it out together in about 2 minutes. Okay, first thing, the directions of this, as I read them a couple of times, you have to kind of make an assumption. You have to make an assumption based on the original description of the page that it's actually going this way. It's actually going portrait style. It doesn't really tell you that, and not landscape style. Wouldn't make no sense, but I guess some yearbooks were in landscape proportions. It tells you that it's 8.5 by 11, so you have to understand that it's going to be 8.5 across by 11 inches tall. Okay, so which one of those measurements does not concern you based on what we're looking at right now? 8.5 or 11? We're talking about how high something can be. We're talking about putting 7 pictures down the page. It doesn't matter how wide the book is. So they gave you an extra measurement right there that's not even going to concern yourself with this problem. 8.5 doesn't even matter right here because we're talking about how tall it is. So the first part about the page tells you that the top margin, this is the part at the top here, is going to be 3/4 of an inch. Then it tells you that the bottom margin, this one here, is going to be 1.25 inches. So this is what you should have been thinking so far, something like this. Okay. Then it says the space between the pictures is 3/16 of an inch. Then it says how many or how high can each be to fit 7, and they even wrote it as a word right there. But that's another number. That's another value that you have to use, 7. Okay. So what we're going to have is 7 pictures. One of them is going to start here. Then it's going to be 7 of them going down. 2, 3, 4, 5, 6, and then 7. Something like that. That's what you should be thinking. 7 pictures. Obviously, my spacing's all jacked up right there, but we're going to assume that it's all the same. It says, how high can each picture be to fit 7 down the length of the page? So what we have is, the total amount of space we have between what I have on there, the blue line and the red line, is going to come from that number 11 on the right hand side. 11 minus 3/4 of an inch, because you're taking away the top margin, minus 1.25 inch, you're taking away the bottom margin. That's the space you have right there on the left hand side. This is the space we have. Equals, now we're going to talk about the amount of space used. We'll just write the word used over here. How much we're going to actually use. Well, we know there are 7 pictures, but we don't know how high. How high has to be a variable because we don't know how much it is yet. So 7 times the tallness of the pictures, or how long they're going to be, how tall they're going to be. So 7 times x plus, how many spaces do we have? If there are 7 of them, how many do we have if we count them up? 1, 2, 3, 4, 5. How many spaces? 6. There's not 7 spaces, there's 6 spaces. It's 6 times, it says the space between each picture. And this is a tough problem. 6 times 3/16. So if you're looking at this thinking, I have no idea, just follow along. We're going to get to the correct answer. This is your equation. 11 minus 3/4 minus 1.25 is equal to 7x plus 6 times 3/16. Okay. So fortunately for these fractions we have on the left-hand side, negative 3/4 and negative 1.25, we can put those two together. They're both negative, so you're going to add them up. 1.25 plus 3/4 is going to be 3, because 3/4 plus 1/4 gives you a whole. It's going to be 2. If something looked funny. 2. 1.25 plus 3/4 is another whole, so you add the 1 whole with the second whole and you get 2 wholes. And it's going to be a negative value because you add them up. So 11 minus 2 is going to simplify to 9 inches. So 9 inches is what's available. That's the available space. Then you just simplify the right side. 7 times x, there's nothing we can do with that yet. Simplify 6 over 1 times 316. You can the number 2 goes into both of these. It goes into 6 3 times and into 16 8 times. So now we're just dealing with smaller numbers. 3 times 3 is 9 and 1 times 8 is 8. So now we have an equation, even though it has a fraction in it. We don't like fractions. We have an equation that's a whole lot more friendly for us to use. Remember, we can cancel out, instead of subtracting 9 over 8, we can cancel out divide by 8 by multiplying the entire equation by 8. That multiplies by 8 this one and this one as well. We're going to get bigger numbers, but we're going to remove fractions, which is what most of us would prefer to do. 9 times 8 is 72. 8 times 7 is going to be 56x, and 8 divided by 8 or multiplied by 8 cancels out, so we have plus 9. Again, we have smaller numbers to fool with. Subtract 9 on both sides. 72 minus 9 is going to be 63 equals 56x. And then we're going to divide by 56 on both sides. And again, we're dealing with bigger numbers. Divide by 56 on both sides. Okay. So 63 over 56. If we want to estimate this, just to speed it up a little bit, we could divide the number 63 by 56. Thank you. Okay, when we punch it in, we're going to get x is equal to 1.125. 1.125 inches. That's how tall each picture can be, 1.125 inches. Okay, the next example is a little bit easier. That was a really tough example to go along with it, but it just shows you one like you're going to see tonight on your homework. It says Sarah and Jim both decide to save some money each week. Sarah already saved $100, and she plans to save $10 a week. Jim plans to save $15 a week, but he doesn't have any money to start like Sarah does. It says, in how many weeks will Jim and Sarah have the same amount? It says, so first write an expression for the amount of money Sarah has saved. Then set this expression equal to the expression for the amount of money that Jim has saved. So Sarah's original savings plus how much she saves each week times the number of weeks equals Jim's amount he's going to save each week times the number of weeks. Notice what's more on Sarah's side is the amount that her original savings. Jim doesn't have that. Okay, so when we label each one of these, we know what everything's going to be. We know Sarah's original savings is $100. We know she's saving $10 each week. These are much simpler numbers than what we just dealt with. The number of weeks, it says how many weeks, so it's going to be a variable. And then Jim's saving $15 each week, so $15. So when we plug each of those numbers in place of Sarah's original savings, we plug in 100. So 100 plus how much she saves each week, 10 times x, equals Jim's amount each week is 15 times, again, the number of weeks is unknown, so it's x. So here's our equation. 100 plus 10x equals 15x. You know to collect your variables on the same side. 10 is smaller than 15, so subtract 10x on both sides. When you subtract it on the left, you're going to be left with 100, and when you subtract it on the right, you're going to have 5x. So 100 is equal to 5x. And then when you divide by 5 on both sides, you get x is 20 by dividing each side by 5. So in 20 weeks, they will have the same amount of money saved. Even though she's saving $5 less per week, she started with $100. So it's going to take 20 weeks for Jim to catch up and be even with Sarah. So it says answer Sarah and Jim will have the same amount each after 20 weeks. It says check. Use a graph to check your answer. Okay, so when we graph this right here, you could plug it into the equation that you have. We know that when you do Sarah is 100 plus 10x. When you do Jim is just 15x. So when you just do it for each one of those, the amount of weeks, if Sarah's is blue and Jim's is red, even though they both red on my screen right here, Sarah at 0 weeks, she had $100. At 5 weeks, so you're just going to have 100 plus 10 times 5, which is 50. So 100 at 5 weeks is going to be 150. at 100 at 10 weeks times 10 plus 10 times 10 is 100 plus 100, so it's going to be at $200. And so on and so forth. At 15 weeks, it's going to be at 250. At 20 weeks, it's going to be at $300. When you do Jim, you're going to do the same thing, except Jim, there's no $100. Notice he starts off at 0. When you do 15 times 5 weeks, you're going to get $75. I didn't write it on the other one. $75. So at 5 weeks, it's $75. At 15 times 10 weeks, it's going to be $150. At 15 times 15 weeks, it's going to be $225. That's there. And so on and so forth. When you get to 20 weeks, notice it's the same at 20 weeks. 15 times 20 is going to be $300. And that's where they even up. That's when you have a graph, you can check the point where they intersect is the point where they're equal to each other. Okay, it says here, try this one real quick. This one's a whole lot easier than the last one we just did. Just know when it says, at what point will it be twice as many, you need to multiply the French side by 2. Okay, take about 2 minutes, see if you can get this one. Multiply the French side by 2. Okay, this one says there's 362 taking Spanish. So let's do a Spanish side, and then we'll do a French side on the other side of the equal sign. Okay. There's 362 taking Spanish. It says it's increasing at a rate, that means plus, going up, plus 20 per year. So 20 times an unknown amount of years, not 2, 20 per year. So that's how you should have it started off, 362 plus 20x equals, the French side says that there's 259 taking French, but this one says it's decreasing. That means it's going down. So minus about 3 per year. So minus 3 times x. But this is the part I told you when you started the problem. It says at these rates, when will there be 2 times as many When will there be 2 times as many French students? So what you need to do is on the whole right-hand side, you got to multiply it by 2. So distribute that 2 to both of them. We'll go faster this. 2 times 3, negative 3x will be negative 6x. 2 times 259 is the same thing as 2 times 260 minus 1. So 2 times 26 is going to be 520 minus 2 is going to be 518 equals 362 plus 20x. So right here, even though they got big numbers, it's a simple equation for you. Add 6x to both sides. You get 26x on the left plus 362 equals 518, and subtract 362 on both sides. We know that 8 minus 2 is 6. We know we have to borrow 1. 1 minus 6 is 5, so we have 156 equals 26x. And when you divide by 26 on both sides, you get x equals, now how many quarters are in $1.50? There's 6 of them. So in 6 years, there'll be twice as many Spanish students as there are French students.